So on this video, we're going to discuss solving quadratic equations by applying square roots. All right, so we are able to solve quadratic equations in many different ways. We've been practicing the quadratic formula, and the quadratic formula works always on any quadratic equation. But we have this really simple equation, this quadratic equation, really simple quadratic equation, and we're going to solve it using many different ways. And of course, we're going to get to the preferable method, which is by applying a square root on both sides of this equation. But beginning with mental math, what number squared gives you 9? We know that the answer is 3, right? So we know that the answer to this guy is x equals 3. And we also know that it could also be a negative 3, okay? Because if you plug in a negative 3 times itself, negative 3 squared, and when you do plug it in, you plug it in with parentheses. Negative 3 squared really is that positive 9 as well. So those are the two answers right there. Now, let's say you really wanted to use the quadratic formula. You could simply subtract 9, set it equal to 0, which do to one side, do to the other side, rewrite it, x squared minus 9 equals 0. And to even make it more visual for everybody, or visually appealing, we're going to rewrite it as x squared plus, there is no x term, there is no bx, but there is that c value, negative 9 equals 0. Then you could identify your a value is 1, your b value is 0, and your c value is negative 9, and you could technically plug it into the quadratic formula, x equals negative b plus or minus square root of b squared minus 4c divided by 2a, and do all that math, and believe it or not, it will give you the same exact two answers, x equals 3 and also negative 3. Why would you want to do that? I have no idea. But anyways, you can do that if you wanted to. Another way of doing it would be to, again, subtract 9, setting it equal to 0, subtracting 9, rewriting it, x squared minus 9 equals 0, and then factoring the quadratic equation, setting it, and then splitting and solving. So if I wanted to, I could think, hey, this guy right here is a difference of two squares, right? I could factor it, thinking what times what is negative 9, that if I combine together is the middle value, which is nothing. Well, that'll be a positive 3 and a negative 3, and it's still equal to 0. And using zero product property, this times this equals 0. I could split it and say the first x plus 3, that could equal 0, and the second x minus 3, that could also equal 0, giving me my two answers, x equals negative 3, and x equals, obviously, positive 3. So those are my two answers right there. Same two answers as up here. But that's still not the best method. If you read the title, it says solving quadratic equations by applying square roots. So with that said, I am going to get rid of this square by doing the inverse operation. What is the opposite of a square? A square root. All right, so I will apply a square root here, and what I do to one side, I do to the other side. The square root of x squared, the square root and the square eliminate themselves. So I will end up with a nice, beautiful x. Now, what is the square root of 9? The answer is 3. However, we must remember this very, very important fact. Whenever you apply a square root in an equation to solve for x, right, or to get rid of the square on an x, you must put a plus or minus in front of your answer. That's something you need to remember always. There it is. When you apply a square root on an equation, put a plus or minus on your answer, okay? That's a detail you have to remember. So on this question number 1, I showed you all kinds of different ways of getting the same exact answer, x equals 3 and also negative 3. The quickest way, well, besides using mental math, the quickest way is to get rid of the square by applying the inverse operation of square root. And we need to remember, when you apply a square root on an equation, when you're solving, put a plus or minus on your answer. So the square root of 9 is 3, but you put a plus or minus in front of your answer. That really means positive 3 and negative 3. Okay, so with that said, let's move this stuff out of the way. There we go, I rearranged things. Now let's do this next question, number 2. We have x squared equals 20. So yes, you could subtract 20, and then you could identify your A value, your B value, which there is no B value, and your C value of negative 20, and you could use a quadratic formula. But why would you do that when you could apply a square root? By the way, mental math doesn't cut it right here. What number squared gives you 20? Well, 4 squared is 16, 5 squared is 25. It doesn't work. You can't think of the answer in your head, right? So we must apply a square root here, a square root there, and remember this fact up here that when you apply a square root on an equation, you must put a plus or minus in front of your answer. So the square root and the square undo themselves. You now have a beautiful single x. And now the square root of 20, again, I said put a plus or minus in front of your answer. Square root of 20, it's not a perfect square number inside that square root, so I must rewrite it with multiplication, 4 times 5, and then I could split the root. I rewrote it with multiplication to get that perfect square number 4. And then I split the square root, and the square root of 4 is 2, and the square root of 5 stays the square root of 5, and there is your answer, x equals plus or minus 2 square root of 5. Okay? Let's move on. Number 3, we have 5 times x squared equals 20. Okay, well, again, if you wanted to, you could subtract 20, set it equal to 0, and you could identify the a value being 5, the b value being 0 because there is no x term, the c value being negative 20, and using the quadratic formula to solve this, but that would be ridiculous, right? See, the deal is this, guys. If you ever have x squared with no other x's, and I should have said that even on the first 2 examples, if you have no other x's, then you could just worry about isolating x squared and getting rid of the square by applying a square root. Now, if you did have another x, okay, like let's say instead of 20, it was a 20x, you cannot say I want to get x by itself and get rid of the square by applying a square root. All right, you can't do that. So if I did have an x, you know what? I might as well explain this. Let's say I had a 20x instead of a 20. What would I have to do? I would have to subtract 20x, set it equal to 0, subtract 20x, rewrite it. I'd have 5x squared minus 20x equals 0. And I could identify my a value 5, my b value negative 20, and my c value being 0 because there is no number at the end, right? And I could use the quadratic formula. Or instead of that, let me erase that. Instead of using the quadratic formula, you could also factor, split, and solve. So you could think, what is my GCF right there? I could pull out a 5x, and I would have x minus 4 left over, and it still equals 0. And then you could use the zero product property. This times this equals 0. That means that the first 5x could equal 0. And also the x minus 4, that binomial, could also equal 0. Giving you 2 answers, dividing by 5 on both sides, x equals 0 and x equals 4. Those are your 2 answers if you had an x right here, okay? So if you only have an x squared and no other x's, let's go back to that. Let's go back to that. How am I going to go back to that? Let me see. I apologize. Let me go back to the original here. So it did not have an x. I could now isolate x, right? I want to get x by itself. What do I have here? I have a 5. I have a power of 2. I don't want that stuff. I just want x by itself. So let's easily get rid of that multiplication of 5 out in front by dividing by 5. What you do to one side, do to the other side. You will end up with x squared equaling 4. And again, I will do the square root and the square root. It'll give me x equals plus or minus 2. Easy peasy. Okay. Again, I forgot to mention this, the previous 2 examples. Only try to isolate x and get rid of the square by applying a square root if you have no other x's. If you do have other x's, you're going to have to set it equal to 0 and either factor, split, and solve, or use the quadratic formula to solve. So right here, because there were no other x's, it's just x squared. I got x by itself, by dividing by 5. I got rid of the squared by square rooting, got my final answer, and I put the plus or minus in front of that answer after applying that square root. Let's take a look at number 4 over here. There are no other x's, right? There are no other x's. So I do not, I can square root to get rid of the square. Now, on a previous class, I asked, you have any idea what I could do here, right? And a certain student said, yeah, you could subtract 25. So I just went with it, right? And I want to show you many different ways of doing this, right? You could subtract 25, and if you did subtract 25, what would you have? You'd have parentheses x minus 3 squared minus 25 equaling 0. Now, at this point, a little bell in your head should be ringing. You should be like, wait a minute, I recognize this right here. What is that? That is a vertex form equation, right? My vertex is technically positive 3, negative 25. And I know that my a value is positive 1, which means the parabola opens up. So if you recognize that, you could technically go to Desmos, type y equals parentheses x minus 3 close parentheses squared minus 25, graph it. It'll be a parabola that has a vertex 3, negative 25 that opens up, that will cross the x-axis at 2 locations, and those x-intercepts are the answers. They are the solutions. So that's one way of doing it. Okay, would I do it that way? Nah, I wouldn't do it that way, but that's one way of doing it, right? What other way could you do it? If you really wanted to use the quadratic formula, you'd have to get the standard form equation ax squared plus bx plus c equaling 0. And of course you don't have that, so you would have to write it x minus 3 times x minus 3 and actually distribute x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is negative 3x, negative 3 times negative 3 is positive 9. Combine the middle two terms, you'd get x squared minus 6x plus 9 equals 25. But in order to use the quadratic formula, you have to set it equal to 0. So you have to subtract 25, giving you x squared minus 6x minus 16 equals 0. And then you could say, okay, my a value is 1, my b value is negative 6, my c value is negative 16. And then you could use the quadratic formula, which would take more time, right? So that's another way of doing it, but I wouldn't recommend that way either. I notice that I have an x in parentheses squared, and there are no other x's involved. So I know that I could get rid of a square by applying the inverse operation, which is a square root. So I could square root this side and square root that side, and I will have x minus 3, no more square. The square, it disappeared because of the square root, equals, now the square root of 25 is the nice, beautiful answer 5. However, don't forget to put a plus or minus in front of your answer. Remember, whenever you apply a square root in an equation, put a plus or minus in front of the answer. So I now need to get rid of that minus 3 by going plus 3. What I do to one side, I do to the other side. Now notice I didn't put the plus 3 on the 5 because it's both a positive 5 and a negative 5. So I put it right here, and I'm going to write it in front. It just looks nicer. It's an easier way to stay organized. 3 plus or minus 5. And now that you see the 3 plus or minus 5, you could do both 3 plus 5 and you could do 3 minus 5 to give you your two answers, 8 and negative 2. Those are your two answers. So if you would have chosen to subtract 25, move it over here, graph the vertex form equation, you will see the parabola crossing the x-axis at negative 2 and at positive 8. If you were to have distributed and rewritten the whole thing as a standard form quadratic trinomial set equal to 0, and you use the quadratic formula, you would get these two exact answers as well. Let's try number 5. And if I'm going too fast, I apologize, but it will be recorded so you could go back and watch it and pause it if you need to. Number 5. So in order to get rid of the square here, I will apply a square root and apply a square root. All I need to do is remember that when I apply a square root, I need to put a plus or minus in front of my answer. The problem here is 27 is not a perfect square number, but we shouldn't be scared of that because we already know how to simplify non-perfect square radicand values, right? The square root of 27, it's not a perfect square number. Let's rewrite it with multiplication to get a perfect square number. That way you could split the root and your final answer will be 3 square root of 3. I probably shouldn't have said final answer, but the answer to the square root of 27 is 3 square root of 3, and there's a plus or minus in front of it. Now, on the left side of this equation, the square and the square root canceled. We have x minus 3 equals plus or minus 3 square root of 3. So I need to still solve for x by adding 3 here and adding 3 over there. And again, notice I didn't put it directly under the 3 square root of 3. I kind of left it in front because that's how I'm going to write it. X equals positive 3 plus or minus 3 square root of 3. You know what? Let me color code it there so it'll even look nicer or easier for you to see. So all I did was rewrite it, and ladies and gentlemen, that is my answer. Okay. Now again, if I were to have written this twice, distributed, combined like terms, subtracted 27, made it look like a standard form quadratic trinomial equation, ax squared plus bx plus c equaling 0, using the quadratic formula, I will end up with this answer. Let's try one more. Now, to be honest with you, if I were taking a quiz and I was trying to rush through this, I would move the 8 to the other side and I would just use a quadratic formula. But because on this section I'm trying to emphasize that you could get rid of squares by applying square roots, I want to do it a different way. Okay, now right now I cannot get x by itself and then apply a square root. Why not? Because there's other x's involved. Okay, so what I do see is that this is a standard form quadratic trinomial that's a perfect square quadratic trinomial. In other words, what times what is positive 4, that if you add together is negative 4, that would be a negative 2 times negative 2. And because it's the same exact binomial, you could actually rewrite that as x minus 2 squared equaling 8. Okay? Now, what does that mean? That means that I now have just the x in parentheses with the square on the outside of the parentheses. There is no more 4x involved or 8x or any other type of x. So I could get rid of that square by applying a square root to both sides of this equation, and I will have x minus 2 equaling, let's not forget that you need to put a plus or minus, and 8 is not a perfect square number, but I could rewrite it as 4 times 2. That way I could split the root. The square root of 4 is 2, and the square root of 2 is the square root of 2. All I need to do now is get rid of this minus 2 right here by adding 2 to both sides. Final answer will be x equals positive 2 plus or minus 2 square root of 2. And that is all. Again, I could have right at the start rewritten it as x squared minus 4x. If I subtracted 8 and subtracted 8, I'd have a minus 4 as my c value set equal to 0. And I could have plugged in my a value of 1, my b value of negative 4, and my c value of negative 4 into the quadratic formula. And after plugging it into the quadratic formula, I should be able to simplify it to get this final answer, the same thing, okay? Which is not a bad idea to use a quadratic formula, right? Anywho, I hope this video helps. The only reason why I did this video is to show you that there's other ways of solving quadratic equations, especially when you only have an x squared and no other x's. In those situations, you could isolate it and apply a square root to get rid of the square.